Hey guys, so just want to talk about the related rate for calculus today. So here are some of the strategies for solving related rate problem. So step one, you always want to make a drawing of the situation if possible. And step two, use letter to represent the variable involved in the situation. So let's say x, y, or z. Step three, identifying all rate of change given and those to be determined. Use the calculus notation dx over dt, dy over dt, etc. to represent them. And step 4, determine an equation that involves both the variable from step 2 and the derivative of step 3. And step 5, differentiate by implicit differentiations. Always, that's a variable. You have to take the derivative implicitly. And the equation up to step 4. And step 6, substitute all known value into the differentiated equation. And step 7, use algebraic manipulation if necessary to solve for the unknown rate or quantity. So here are some of the formula that you need to recognize. So the volume of a perfect cube is always the size to the power of 3, and then volume of a cylinder, pi r squared times the height, and the volume of a rectangular prism, it's length times width times height. Sphere, 4/3 pi r cubed, and then a conical cone, so which is what, pi r squared h over 3. And then volume of a square base pyramid, it's base times the area of the base times the height over 3. And here's one of the problems that with the related rate. A ladder is 10 feet long, is resting against a wall, and the bottom of the ladder is sliding away from the wall at the rate of 1 foot per second. How fast is the top of the ladder moving down when the bottom of the ladder is 8 feet from the wall? So first you want to draw the diagram. So the ladder, it's always considered constant, so it's 10 feet. And then sliding down against the wall, so we do have a rate of change for this one. So let's say that the variable, the height, it's y. And then the rate of change would be dy over dt. And then this one is getting further away from the base of the ladder. So let's say this one's x, and the rate of change for that is dx over dt, which is 1 foot per second. So first thing that you want to do is that make sure dx over dt is 1 foot per second, and we want to find out dy over dt. And by using the Pythagorean theorem, we do have x squared plus y squared equals 10 squared. And differentiate both sides of the equations with respect to t. So here's what we come up with: 2x dx over dt plus 2y dy over dt. And derivative of a constant, the result is always 0. And then we try to solve for dy over dt. So isolate the variable dy over dt on one side, so take everything else to the right hand side. So we end up with negative x over y times dx over dt. And then the next step, you want to plug in the number. So when x is 8 feet, so we have square root of 10 squared minus 8 squared, so which is 6 feet, because we need to find the height. And therefore, so we got dy over dt equals negative 8 over 6 feet, and then times 1 foot per second, so that equals negative 4 over 3. Don't forget about the unit. The unit is considered feet per second. It's about the rate of change. It's how fast the ladder is sliding from the wall. And the top of the ladder is sliding down because of that, the negative sign, so that's why it's considered negative, and that the rate of 4/3 feet per second. So for another video I'm going to post up later, so we're going to put in more related rate problem. Thank you for watching it.